Hello everyone, I'm Gaurav. So today I'm going to discuss about my assignment which is based on machine learning. My assignment is divorce prediction using machine learning. In this assignment, we are going to discuss the whole process of creating machine learning models for the divorce prediction. So I've taken the dataset from this link UCI machine learning repository. So here's our dataset. Uh, this dataset provides you all the relevant information needed for the prediction of divorce. This dataset contains 54 features, and on the basis of these features, we have to predict that the couple has been divorced or not. Value 1 in our dataset represents that the couple has been divorced, and the value 0 in our dataset represents that the couple has not been divorced. So some of the features are as follows, like feature 1 is when one of our apologizes when our discussions go in bad directions, the issue does not extend. Second feature is I know we can ignore our differences even if things get hard sometimes. Third feature is like when we need it, we can take our discussions with my wife from the beginning and correct it. So, like these, there are 54 features in our dataset. The dataset itself contains 170 rows and 55 columns. As we have seen our dataset, and we also have relevant information about the dataset. Now we will implement various machine learning algorithms on our dataset, and we're also going to do the data pre-processing, and here we will also check the accuracy score and confusion metrics for each of the machine learning algorithms. So now we are going to see the code. So here, firstly, we will import all the libraries needed to build the machine learning models. So here I have imported all the libraries. Here import numpy as np is for the library for the linear algebra. Import pandas as pd is for data preprocessing. Import matplotlib.pyplot as plt is for data visualization, and these are the algorithms which will help us to build our various machine learning models. Here I have read my dataset file which is in the .xlsx format. So in data pre-processing, we converted our dataset into pandas data frame. Then we created two different datasets from this dataset. One is the data values and another is the label of the data values name as x and y using the slicing method in Python. Then we divided our dataset into training and testing dataset in the ratio of 80 to 20, 70 to 30, and 60 to 40. We can select the import features and observe how much a feature is affecting our prediction. So here for this, we used the Pearson correlation matrix and plotted this graph. Now we are going to build the machine learning models. First, random forest classifier. Firstly, we took random forest algorithm from scikit-learn then we fit the data in three different ratios, that is 80 to 20, 70 to 30, 60 to 40. By this, we get the output for our random forest classifier. Here we get the accuracy score for a dataset and confusion metrics for a dataset. So if you observe here, we have got the three different accuracies and three different confusion metrics. It's because we have fed our data into three different ratios. That's why we get the accuracy and confusion metrics for our each fit. Now moving on to logistic regression. Logistic regression uses sigmoid function and is basically a classification algorithm. So to create logistic regression, so to create regression object, we will again use sklearn and we will fit a data into three different ratios, 80 to 20, 70 to 30, 60 to 40. That we get the output for the logistic regression. Now for confusion metrics and accuracy score, here is for the confusion matrix, CM1 equals to confusion matrix for y-test, comma result predictor for the x-test, and for the accuracy score here and we get the accuracy for our three different bits and also the confusion matrix for our three different bits. Now niche bias classifier. We will use sklearn to import Gaussian NB and to create Gaussian NB object, and then we will fit data into three different ratios, 80 to 20, 70 to 30 and 60 to 40. By this we will get the output this. Now for the accuracy score and the confusion matrix. For accuracy score, we'll get the accuracy for three different fits: 0.9411, 0.960784, 0.97058, and the confusion matrix for the three different fits. Now we will implement SVM, that is support vector machine. In this algorithm, the data points are plotted on a plane and a hyperplane is created to separate those values so that we could classify which data belongs to which class. And we can separate them by a hyperplane. So to implement this algorithm, we will use sklearn to import SVM object, and then we'll fit a data into three different ratios. So for SVM we get the output. For accuracy, by putting this, we get the accuracy for our three different bits: 0.941176, for another fit 0.960784, and for the third fit 0.970588. And like this, we'll get the confusion matrix for our three different fits. Now we will implement the car decision tree. For this, we will use sklearn to import decision tree, and for car decision tree we will use the criteria of Gini index. But for ID3 we use the criterion entropy. We will fit the data into three different ratios: 80:20, 70:30, 60:40, and we will get the desired output for the decision classifier. Now for confusion matrix and the accuracy, here we import the library for the confusion matrix, and for the accuracy score we have imported the library. So we get these accuracies for our three different fits: 0.9411 for first fit, 0.96078 for the second fit, 0.95588 for the third fit, and the confusion matrix for our three fits. Now moving on to neural network. In neural network, there are several layers which works on the basis of the structure and functions of human brain. It consists of neurons which get the input and then produce the output to the next consecutive layer neuron, and hence we get our desired output. So to implement neural network, we will use these libraries, and as we discussed on the starting of the neural network, we'll give the input, and then we are going to and then we get our desired output for the neural network. So for the evaluation metric, that is accuracy, and we also have so for the accuracy we will get the accuracy for each sample like this. Now moving on to perceptron. Perceptron is an algorithm for supervised learning of binary classifier. It enables neurons to learn and process elements in the training set one at a time. So now let us implement the perceptron algorithm. Firstly, we are using scikit-learn. We import the library for perceptron algorithm. Then for the perceptron, we fit the data into three different ratios: 80 to 20, 70 to 30, and 60 to 40. So by this, we get the output for perceptron. Now for the confusion matrix and the accuracy score, for confusion matrix we get the output, and the accuracy for first fit we get the accuracy 0.9411. For the another fit we get the accuracy 0.960784, and for the third fit we get the accuracy 0.955882. So we have discussed about all the machine learning models. So now moving on to evaluation metrics. We have implemented the accuracy and confusion metrics for the all machine learning models in our above explanation. So now explaining what is the accuracy and what is the confusion matrix. So first, accuracy. Accuracy is the ratio of number of correct predictions to the total number of input samples. So accuracy for each sample has been displayed above like this. Now moving on to the confusion matrix. A confusion matrix is a table that is often used to describe the performance of classification model on a set of test data for which the true values are known. It allows the visualization of the performance of an algorithm. So like here I've taken an example of the confusion metric of a random forest classifier. So in here the first row is about the non-diverse prediction. 19 couples were correctly classified as non-diverse, and 0 were wrongly classified as not diverse. The second row is about the diverse prediction. Second, 2 couples were wrongly classified as diverse, that is false negatives, and 13 were correctly classified as diverse, that is true positives. So we have successfully trained our dataset in two different models for predicting whether a couple will get divorced or not, and also got the accuracy and confusion matrix for each model as well. And I'm also providing the link for the code in my blog. So here's my blog, and here's the link for my code. So if you want to check my code, then check it out. Thank you.